So we're going to start off this morning with a really quick demo, introduction to Puppet. So just a quick show of hands, how many of you guys are just starting with Puppet, just trying to figure it out? Maybe you're using another tool and you're not quite sure. Okay, perfect. Yeah, that's exactly what we're using. Pretty standard, right? So today what we're going to show you is we're going to show you Puppet Enterprise. So a lot of us are familiar with Puppet Open Source. That's kind of the thing that's made Puppet Labs who we are. We feel that we are the de facto standard when it comes to configuration management and automation on systems. So by showing Puppet Enterprise today, what I hope to give you an understanding of is kind of not only how you can start to manage, and start to configure your machines, right, and start to get some automation, but how you can start to tell the rest of the story, right? Having an agent out there that's making all these changes and automating all these things for you is great, but if you don't have visibility into what that's doing, you've got a whole other set of problems. Or if you're not version controlling all your configurations, right? These things just kind of introduce more and more problems, and we feel like we've solved a lot of those problems with our enterprise product. So just a quick background on me. My name is Spencer Sebald, Solutions Engineer with Puppet Labs. I've been with Puppet for about 2 years now. I started when there was about 150, 140 people. We're almost at 400 now. Before coming to Puppet, I was a Windows sysadmin. So I managed, I would roll out all these Windows SQL Server clusters at VA hospitals around the country. It was manual. It was about as awesome as you can imagine, and really happy to see Puppet move in that direction and see how you can start to automate a lot of those really painful things. All right, this is just a quick slide to kind of show you some of the problem spaces that we try to tackle with Puppet Enterprise. So obviously we have Puppet as the core thing that's going in, making all this change in your systems. But then again, we're bundling in a reporting structure so you have visibility into what's happening, orchestration engine that allows you to communicate with a lot of your machines in real time, just a bunch of other tools. I'm just trying to get away out of the way of the bright light here. So let's take a little quicker, higher level dive into how it is that Puppet works. So first and foremost, we're all about infrastructure as code, right? We take all these manual configurations, they're probably hiding a script or a build document somewhere. Maybe you go in and tweak those things manually. We're looking to translate those into what we call Puppet. So Puppet uses its own domain-specific language to define what state the machine is to be in. So it's important to note here that we are a declarative language, not an imperative one. Can everyone still hear me okay? Okay, well, I just hold this. Okay. There we go. Is that better? Cool. Perfect. Oh, that's fine. I'll get used to it after a while. My eyes are still adjusting, I'm still waking up. But anyway, so we're a declarative model and not an imperative one, right? So in this case, we just have to tell Puppet what state we want the resources to be in, and it does all of the, it figures all that out behind the hood or under the scenes for you. So it's like, I want to make sure that a service is running or a user is created, all those different things. There's a ton of different ways to do those across all those different operating systems, and Puppet figures those things out for you. So again, we just have to define what state we want those things to be in, and it's going to figure that out. One of the beauties of also treating our infrastructure as code is we can now start to version control these things, right? So now we have this code snippet. It's defining what state our infrastructure should be in. I can now commit that up into something like Git. We can have a lot of cross-team collaboration. We can check out, do merge pull requests, all that sort of thing. I can now roll back my infrastructure if I need to. So if I actually push out a change and I say, hey, maybe that change isn't exactly what we wanted, let's go ahead and burn these machines down. Let's point to a different commit, and now we can rebuild these machines just as they were before we actually pushed out our change. Again, it allows us to make changes even more quickly, right? Because they're all documented in a single place. Your Puppet code starts to become a self-documenting language as to how things are done and why they're in a certain state. So once we've defined the desired end state for a particular machine, within Puppet we have two different actions we can take. We can have the Puppet agent enforce that change, right? Where it goes out, it's looking to actively remediate any sort of deltas. Or we can have it just simulate the change for us as well. So Puppet has the unique ability to be able to simulate a change. Well, let's say I want to push out Tomcat on one of my Red Hat I'm going to tell Puppet, in this case, what would you do to get this machine to match that desired end state? And it will tell us all those different steps. So it would create users, manage files, restart services, all that sort of thing. And we can just have it give us a report back based on all those actions. Enforcement's really Puppet's bread and butter, right? So by default, we have an agent. That agent's installed on all the different machines you want to manage. Those agents effectively check in with what we call a Puppet master every 30 minutes. And it's looking for any of that drift, and it's looking to actively remediate any of that drift. And we'll take a little bit closer look at a Puppet run here in just a second. The last stage here with Puppet Enterprise is then we report on all those things that Puppet's doing. So we have a web UI that's going to give you all the reporting back. It's a lot of feedback, right? We want to know when files are changing or services are changing, all that sort of thing. And Puppet's going to give that to us in a graphical format. So now you can give that to your managers. You can say, yes, we're fully patched, or yes, that change went out, and it was successful on all these different machines. So I like to make these things as interactive as possible. So if there are any questions as we go through this, please interrupt me. I'm more than happy to answer any questions and go down any route that would be most useful for you guys. So definitely don't be shy. Go ahead.
That example that you had said you got this mounted for a Linux machine, what would happen if that were actually
Yeah, so, yeah, absolutely. The biggest thing that would happen would, Puppet would complain that it wouldn't be able to find that particular file structure. Because Linux and Windows are totally different. That would probably be the first error that would happen. Next, it wouldn't be able to find service SSH, so it'd be kind of a nested problem there. For the most part, though, if we had a service that was named the same thing on Windows and Linux, and all we said in this case was just enable true, ensure, or ensure running, enable true, it would know how to do that on across multiple operating systems. Not at all. If you have a custom service, a lot of folks will manage those things with PowerShell. PowerShell is awesome, and we have native PowerShell support. So being able to even kick off scripts within your Puppet code, what I've found, at least from a Windows perspective, we've got a ton of modules on the Forge that describe different aspects of Windows, so things like registry keys, roles and features, and that sort of thing. But there's about a 10% gap there where Puppet's not quite there, where there's still some things in Windows that you can't quite do, and that's where PowerShell really helps fill that gap. Any other questions? All right, cool. Let's jump to the next example here. This is just another example of some Puppet code, right? So one of the things that we like to try to get across for new folks especially is that this is not a scripting language, right? It's a very human-readable language, all defined in key pair values. Where again, we're just telling Puppet what state we want those things to be in, not necessarily how to get to that state. So that's where Puppet really starts to differentiate itself from a lot of the other tools in the space. Where instead of, again, telling that machine how to get to that state, we just tell it what we want it to return. All right, so let's dig into a Puppet run really quick. So we have a node, it's sitting out there, it's doing something, right? It's a web server, it's a database server, it's performing some sort of business value within your organization. Then on the bottom here, we have a Puppet master. So a master is what stores all of our configurations. This is your certificate authority, it's your Puppet database, it's doing all these different services for Puppet. The first thing that node is going to do is it's going to submit a set of facts about itself. So one benefit of having a Puppet agent on the system is it automatically starts tracking a lot of your inventory for you. So a lot of your assets that are out there, Puppet's going to discover those once we get the agent installed. So things like hosting or OS family or patch level, IP address, those types of things, we track those in what we call facts. Facts are really what drive all the different actions within Puppet. So when we start thinking about, how do we get particular configurations on a machine, or how do we make sure that these machines stay in a particular state, right? All of those things are being driven by facts. So facts are going to essentially direct Puppet where it needs to go. So basically that node's going to submit its facts to the master. The master's going to say, okay, great, so you're a RHEL machine, you're at this patch level, you have more than 4 CPU, and you're in this data center. Cool, that means that you get Apache and Tomcat installed and configured this particular way. So those instructions go back to that node in the form of what we call a catalog. So a catalog is really just a bunch of JSON instructions telling that machine how to get into that state. That machine's going to compile that code against itself, and then lastly, it submits a report back saying these were all the things that were successful. Maybe these different pieces weren't so successful, so maybe we need to rerun those, or maybe we need to get eyes on, right, because our code's buggy. Any questions on a run? Go ahead.
Is step 3 done at the Puppet master, or excuse me, step 2, is that done at the Puppet master?
Yes, yep, the master compiles the catalog and then ships that down to the agent. The agent's responsible for compiling all those things against itself, but the master does have to create the catalog. Cool, and then this last slide out there is just mostly for the newer folks, right? You see something like, there we go. So you see something like Puppet, right? And you think, I've got all these awesome scripts, they do this for the most part. You know, why would I take all the time to translate those things into Puppet code? You know, and then to think about, now I not only have to manage my operating system configs, but then the middleware and the applications and all that sort of stuff. So a very, very common kind of adoption curve that we see for Puppet is really folks will start off at the operating system level, right? A lot of those things that suck the most, you know, you would think in 2015 we've solved, or we had a good way of rolling out NCP, right? You know, how many times does time bite you? And so that's, you know, those things that suck the most are what usually we recommend you put in a Puppet, because they're also pretty easy to manage. So, you know, your SSH configs, your NTP, your sudoers, all that type of stuff. And then as you get more comfortable with the tool, then start moving up the stack. So next we start looking at our middleware, so things like Apache, Tomcat, JBoss, all those type of applications. And then lastly, we can also do code deployment. So, you know, actually taking that code out of a version control system that your devs are committing to, maybe kicking off some sort of Jenkins, you know, continuous delivery type job, pushing that out to your Puppet master through Git, and then having Puppet actually push that out to the rest of your machines. It can be a pretty powerful workflow, but those are obviously, you know, phase end type operations. All right, so let's start doing some stuff. How's that? Any other questions so far? Everything's pretty clear? So, perfect, how's that? All better? There we go. All right, so we're actually gonna jump on the command line a little bit. This is a Puppet master machine, and can everyone see that in the back okay? Is that relatively clear? For the most part? All right, cool, let me know if it's not. So one of the things that we're gonna do first is we're actually gonna have Puppet start describing itself to us. So I wanna really show the power of having an agent on each machine here. So again, this is a Puppet master machine, CentOS 6 VM, clean install. Puppet's not really doing anything, it's running successfully, but I haven't given it any end states, right? I haven't told it what I want any other machines to look like or anything like that yet. So first, you know, let's pretend we're just getting started with Puppet and we're trying to figure out this Puppet thing at large. So I want to start managing some of my users with Puppet. So these are going to be local users on the system. I want to discover what those declarations would be in Puppet code. So I'm going to have Puppet describe to me the current state of all of my resources, in this case, all my user resources in Puppet code. So here we can type a command, Puppet resource user, and we get all of that feedback from our Puppet master. So these are all the user accounts currently on the system and what state they're in. So we haven't written this code at all. This is again just Puppet describing the current state to us in Puppet. And we can do all sorts of things with this resource command. We can do things like Puppet resource package, and we'll get similar feedback where we can see all the packages currently installed as well as their versions, services. We can even install really neat modules that will essentially unlock additional resource functionality for us. So things like the Augias providers module, if anyone's familiar with that one. So here's really quickly what a package looks like in Puppet. But you know, again, we can do even things like Puppet resource, sysctl, for instance. If I want to see what all my sysctl settings are right now, and instead of templating the entire thing, maybe I just want to manage a single line item in that file. We can start getting those things out as resources and just have Puppet describe it to us. So the really cool thing here is since this is all just usable Puppet code, we can actually take the configuration for just the user root in this case. Everybody cares about the user root, at least you should. Pro tip there. And that one's on the free So we can actually just take this out and we can save it to a file, right? We can start to have Puppet generate the end state for us within our environment, and then we can start to push this out to multiple machines. So this is how we can, kind of take some of those golden image machines, those machines that maybe you kind of handcrafted over the years, and you say, I want to replicate this n number of times, but I don't just want to snapshot it, right? I want to start to learn a little bit more about how the configurations are on there. Because what happens if something happens to that snapshot? Then you're really at the breach, right? So let's go ahead and crack this open, and let's make some modifications, just to kind of show how Puppet starts to make change and that sort of thing. So we've got a declaration for the user root. Let's start to change some things. First, I'm going to tell Puppet that I don't care about different pieces of this user. So things like comment, GID, those things can change all day, I don't care. Password, min, max age, just go ahead and get rid of those too. Let's say that all I care about on all of my RHEL machines is that the user root is present, has a home directory, it's got a particular password, and this is a hash password, and then a shell. But let's say I don't want my shell to be bin bash, I want to change it to bin sh, and then we'll just keep the rest here. And let's go ahead and just really quickly, let's go ahead and change the password for user root. Awesome. Put it on the screen for you. And let's go ahead and audit that change really quick. So I'm just going to, again, tell Puppet, ask Puppet what the current state of the user root is. Let's cat out our test.pp file, just so we can kind of visualize some of these changes before we actually implement them. So again, as humans, it's really easy for us to look at this and be like, yeah, the hashes are different, I would change the password, and the shells are different, right? But I want to make sure that before this agent that's running out in my environment, that's running as root, by the way, makes any sort of change, that it's going to make the changes I'm expecting, right? So in this case, let's go ahead and trigger a Puppet apply. I'm sorry?
Clear, please. Clear,
Oh, clear, sorry.
Yeah.
There we go. Sorry about that. Definitely let me know if that happens. I know it's kind of hard to see over the table. Cool, so we're going to do a Puppet apply run. So here we're going to run this Puppet code locally, so that user root configuration, we're going to run that against our current system. And here we're going to throw on that simulation, we're going to throw on a flag that essentially puts us in simulation mode. So here we're saying no op or no operation is equal to true. So we're going to run that, and I'm going to expect two things that Puppet's going to tell me, right? It should only change the user root's password, and it should also want to change the shell, and that's it. It's not going to want to drop and re-add the user or anything like that. And here we can get that feedback from the Puppet agent. It's saying, yes, I would have changed those things, but I didn't, because we're running in that no-op or simulation mode, right? On the back end, this is triggering a graphical report all through our web UI. So again, very, very common testing procedure for a lot of folks is they say, I want to run this code first, I want to audit my reports to make sure that, yes, this is what we saw in dev, QA, and before we move into production. Make sure all those reports match up before we actually make it deploy. Really helps with any sort of that disaster recovery or inconsistencies between environments. So perfect. This is exactly, go ahead.
So no-op actually submits the packet changes into like WDP or something else?
Yeah, so running in an apply mode is a little bit of a cheat right now. If I wanted to have this submit a report, basically what we would do is we would do Puppet or report server, and then I would give it a report server. If I wanted it to submit a report for an apply run, this is different from a Puppet agent run. So there are two different ways Puppet can run. It can run in apply mode, which you can think of as like a development kind of testing mode, and an agent run where it's compiling that catalog. So you remember back to that slide where there's that catalog that got shipped to the agent? That's the only case where it will submit a report. Unless we explicitly do a report server. What's that?
If it was running in agent mode with no op, it would
Yep.
submit the report?
You got it. Yep. Exactly. Good question. Cool. So let's go ahead and run Puppet. Let's go ahead and just, we're going to remove all the flags. We're just going to run a Puppet apply. So this is going to move us into that enforcement mode, where now Puppet's going to look to actively remediate any sort of drift, right? So in this case, it should only change two things, and that's exactly what's happening here. It's changed our shell, it's changed our password. We're now in compliance. There's now no more deltas between our defined end state and the current end state of this machine. And so now we can run Puppet all day, and it's not going to do anything else, right? Nothing else needs to be done in this case, so it's not going to do anything. Any questions on any of these pieces? so far? Everything relatively clear? Go ahead.
Is there a way to profile most of the Linux machines somehow?
Yeah, I mean, you can run these Puppet resource commands. I mean, there's a ton of different resources that you can figure out. So I can do things like Puppet, resource, firewall, if I want to see all the IP table rules on the box. There's a lot of different configurations. And again, we'll touch on the Puppet Forge. Think of the Forge right now as like the app store for Puppet, right? It's like, I need this new configuration, where do I get it? I also don't want to build it myself. So the Forge actually allows you to extend a lot of these types as well. So for instance, once you download the IAS module for Windows, you can now start doing things like Puppet Resource IAS app rule on a Windows machine, and you'll be able to get those different configurations. But out of the box, Puppet's not going to know about those. Cool, good questions. Anything else? Yep. It only applies to the local machine. So that's why the apply command it's a great kind of development tool. So like when I'm testing my Puppet code, I'll usually run it just locally in an apply mode, because I don't want to worry about any firewall, or network connectivity out to a mass or anything like that. I just want to do everything locally.
That's also how you do what you're doing.
Yeah, exactly. Yep. Cool, so let's go ahead and crack open just a little bit more complex example here for OpenSSH. Just so you can kind of get an idea of how we start to take these snippets of code and we start to build something with them, right? We start to profile exactly what a machine should start to look like. So here we've got OpenSSH for a Red Hat machine. Here we can see first and foremost, we just have a package, right? We can be as simple as we want or as complex as we want with our Puppet code. So in this case, I just have a package, I know what it's called, I don't care how Puppet installs it, right? Go ahead and use default yum, go ahead and just pull it from a public repository, do whatever you want. I'm just gonna ensure it installed in this case, right? I don't wanna mess with it. Go ahead.
If it couldn't pull it from the digital repository, then it add one in to do so, or that's what you're actually fine?
Yep, it would fail in that case. Yep.
The Puppet colon, what that means?
I'm sorry, where are you at?
Yeah, I mean, source healing, then Puppet colon. What's the Puppet colon?
Yeah, that's a great question. So your Puppet Master also acts as a file server. So this gives us the ability to actually template config files or binaries, even if you want, and just keep them locally on our Puppet Master. A lot of folks will prefer that over, setting up shares or whatever, mostly because the Puppet Master already has all the connectivity needed between those machines. So you can just have Puppet serve those out for you.
Puppet's defined in the Puppet server. So, Puppet server.
Exactly. Yep. Exactly. So within your Puppet agent is defined by what we call a puppet.conf file. So it's just a configuration file. So and we point it to whatever the file server should be. Good questions. So here for a file resource, you can see we can really configure the whole, every aspect of a file. Here we're templating the entire file. So I'm saying this is the template. If anyone even goes in and adds a white space to this, I want you to, basically blast over it and replace it with this version. But again, we do have the ability to manage individual file or just line items in that file as well instead of the whole shebang. And then lastly, we have a service here. The service, we subscribe it to that file. So if Puppet ever needs to change anything in that file, it's just going to refresh the service for us, right? So really just very basic package file service type architecture. It's very common. Go ahead.
Can you give some context of where you're sitting in the file system?
I'm sorry?
Can you give us some context of where you're sitting in the file system?
Yeah, so on the file system, this translates to your modules directory and then...
Where you're physically right now when you're editing the file or whatever?
Yeah, so we are actually in our modules directory. So here, every Puppet Master has the concept, or now every Puppet Master has the concept of environments. So you can think of an environment as being like a branch in Git. So here I'm in my production environment, and then in a folder we call modules. So modules are your snippets of Puppet code that you've created. If we go ahead and take a look at all the things I have in my modules directory, these describe all the things I want to manage with Puppet, right? So whether it's .NET or Java or whatever, all those things live in a single place.
I'm certain that all those files, is there like an Apache instance of WebDAV or something like that? Is that how it does it?
Yeah, exactly. So, and we'll get into that a little bit, but yeah, absolutely. Any other questions?
We should have released the questions.
Oh, okay, sorry. So the question was where all of your code lives on your Puppet Master, and that's what we're showing you right now. It's just it lives in your modules directory. We have an environment. That environment ties to a Git branch in an ideal environment, and then those are built out through whether that's code from the Forge or in a version control system or something like that. Cool. All right, so let's go ahead and jump up into the web GUI, and let's kind of take a tour of what a lot of this stuff looks like, kind of not just on the command line. So let's go ahead and make sure that everything's fitting. Is that a little too small in the back? Should I blow that up a little bit? A little too small? Let's see. This res is probably going to get really ugly really fast, but that a little bit better? More or less? Okay, cool. All right, so this is the Puppet Enterprise Console. So when we start to look at, again, Puppet's doing all these things in my environment, how do I get visibility into a lot of those things? How do I start to orchestrate what machines should get particular configurations, right? How do we define different subsections of our environment to make sure that Puppet's managing them correctly? So the way we do that is here through the Enterprise Console. The Enterprise Console, again, is going to first and foremost give us the status of all of our machines. So if we start to look at right away, I can see that I've got 11 VMs in my local environment. On my laptop here, 4 of them are unchanged, 7 of them haven't recorded in a while. But again, if we had any sort of simulation run, we'd be able to see that. Any failed runs would get visibility into those as well. So again, just the ability to very quickly see what's happening, why it's happening, and then get to the bottom of that. All of the machines that you're managing all show up here in a central place. So whether that's Windows machines or Linux machines, maybe it's even like your F5 load balancer or some of your, maybe it's a NetApp device or something like that. We have the ability to manage those as well, and those would all show up centrally. And again, we can very quickly see what state each of those machines is in. They're all listed here about the last time that they checked into your Puppet Master, right? So if we think back, we have an agent installed on each box. That agent is checking in every 30 minutes by default. And every single time, they're submitting a report based on the outcome of those runs. From here, let's go ahead and drill into an individual machine here. I'm just going to pick on my Puppet Master machine. This is kind of like looking at its profile. We can very quickly see all the groups and classes that this particular machine is a part of. So again, high visibility into why this machine is configured a certain way, right? It's not just all hiding in a snapshot or a template somewhere. We can very quickly see what pieces of Puppet code are configuring it a certain way. We also can see all the most recent reports. So here I can see I've got a couple simulation runs that I've done. I've even got a couple failures, right? This is a production environment. This is very interesting to me. And then lastly, it looks like my VMs have died at some point. But we can also see a lot of inventory information here. So basically, all those facts that Puppet's creating or tracking for us, right? Things like IP address and hosting and things like that, all are visible here through the console as well. So as we start to look at, maybe we want to use Puppet to reinforce our inventory system that we have out there already, or just figure out what we have out there, right? Puppet can provide a lot of value in that case. So let's jump over to classification. So we use what we call a rules-based node classification system. That's kind of a mouthful. But basically, this allows us to take a lot of those facts about a machine and kind of filter it through a funnel, right? So as we start to look at, maybe we want to have a baseline profile for all of our Linux machines. And maybe this is a whole bunch of system tunables, this is setting up SSH and all those things. Well, how do I make sure that my Linux code doesn't accidentally get applied to all my Windows machines, right? And it's going to give me a whole dashboard full of red text when that's not really what I wanted. Or how do I make sure that my Red Hat 6 configuration doesn't go to all my 5 machines and all that sort of stuff. So here again, we're going to use those fact values as rules. So here we can do things like we can regex based on the host name if we want to. Maybe it doesn't match a regex, all that sort of thing. We can see how many machines would match our particular rules. So in this case, no machines match that rule. But in this, we can also do things like OS family is Red Hat, or whatever we want to do. We have a lot of control here over exactly what these rules are and how they're going to get pushed out. So one of the really cool things here is instead of just kind of blindly writing rules or writing regex code and hoping that the right machines fall into the right buckets, we can actually see which nodes would match our particular rules before we commit any of those changes. So again, we're just kind of staging all of our stuff right now. We want to make sure that, yes, nothing's sneaking by here. There's not, some weird character in there that's making it fall into a different bucket or something like that. Classes is where we can start to put some of that Puppet code on a machine, right? So this is all that code that's configuring all those different end states. One of the really cool things about the console is if you think back, maybe into your environment, you don't want to be the only person that folks are coming to for questions about Puppet, right? The whole idea is, I want you to be able to self-service yourself, right? Like, I want you to be able to say, you need a new VM, you need it with these things on it, right? You don't care about the hardware, let me worry about that. But here is how you can get those configurations on your machine in a consistent fashion without me just turning over the VM and maybe you have to hand configure it yourself, or maybe you have to wait for 2 weeks for it to kind of get passed off from team to team. Here through the console, we can really prevent a lot of folks from, who maybe don't know anything about Puppet, or maybe they don't know anything about Linux, but still allow them that self-service capability. So here, for instance, I want NTP to be on all my Linux machines, right? So maybe I don't know how NTP works on a Linux box. Maybe I don't know how Puppet code works for NTP. Well, in this case, all I would need to do is specify, here's my code for NTP. Maybe I have a build document that says make sure NTP is pointed at these servers. I could just pass that here through the GUI, and now I can update in self-service without having to worry about all those underlying configurations, right? I'm essentially gating who can do what and how they can do it.
How
Yep,
is
go
that production environment defined in this?
Great question. So the question was, how is the production environment, so you'll see here it says environment production, defined within the dashboard. So if we go back to our node groups, here we can actually specify what environment we want. This is just looking at the environments on my Puppet master. So again, going back to, your Puppet master should be tied into a version control system. So let's say we're tied into Git. Each of these environments would effectively be a Git branch. So we have a repository, there are a bunch of branches. So if I had, like a test, dev, QA, staging, all those, this would also show up here as well. I could also pin in an agent specifically to an environment. So environments here mean environments for your Puppet code, not for your machines, right? So that's kind of a difference. So a lot of times folks will actually pin an individual machine. You say, hey, this machine's in test. So it also only gets the test version of my Puppet code. And that's how we can kind of pin these things out.
Is the environment in one level up from these groups, so you can't define a group that points to a particular environment, like this is my production server group?
You absolutely would do that. Yep. Go ahead.
So when you were passing parameters to the NTP module, is
Yeah.
that automatically parsing the code to see what parameters are valid?
Yeah, so you can actually build a lot of those checks into your Puppet code. So Puppet has a lot of functions like validate Boolean, right, or validate array, those types of functions that make sure that, yes, what you're passing in, I asked for a number, you're not passing in alphas kind of thing. So we can absolutely do that. But essentially you would build out your Puppet code to be able to parse an array, comment delimited, and that kind of thing.
But the console automatically parses your code. You don't have to tell the console what are valid parameters to NTP. It just looks at the NTP module and says, I know these parameters, like real time.
Yeah, so it's going to by default show you what the default parameters are for that particular thing. So for instance, if we go to servers again, here we can see that there's no default value for servers. This is actually a required thing. I'm sorry? Oh, I would try. Is that a little bit better? Okay, cool. Yeah, but basically this is, if there was a default value here, we would say like, server 1.5.
What I'm saying is, if you write a custom module,
Yep.
it's not like you didn't get off the board or anything. It could ship with
That would automatically show up. Yeah. Yeah, so basically your Puppet console is recursively scanning your modules directory. It's doing a Puppet parser validate basically on all your Puppet code. So the only code that shows up here is code that will compile, which is a good check, and also it'll auto-discover new parameters for you.
So you write a module with value required numbers and
It will tell you what the default is. So in that case, it would say, you know, expecting a number, right? But in that case, if I apply that to a machine, it would still let me do that. But we would get that feedback on an agent run through failure report.
Is
Yeah.
there a way that, I think, what he was alluding to, is there a way to define, these are a set of valid values for this parameter?
Gotcha. You would define that in your code, but in terms of making that visibility to the end users, the only way we could do that is by kind of showing them an example.
So you can't define those in code and then come in here, select your.
Yeah, we couldn't like populate a drop-down box or something, right? Or a radio button or something like that. Yeah.
So that's one feature you can
That's a great feature request. Yeah, absolutely. Cool. So one of the really cool things about the console, it's now backed by role-based access control too. So this is going to tie into a AD or LDAP environment. So being able to again say, hey, based on this group that you're in AD, you should only be able to administer things in this way. Or cool, you're a manager. I don't want you touching on my server. But you certainly can view reports, right? You know, that sort of thing. We also can start getting visibility into, hey, all my RHEL machines changed at 8 p.m. Oh, cool. Well, it looks like Spencer was in there at 8 p.m. and he updated the classification from this to this, and that's why that change happened, right? So getting visibility into those things and really being able to track when change happens is pretty cool, right? And that's something that's usually pretty difficult to do without tools like this. Again, let's just really quickly look at just the access control piece. Again, tying into AD or LDAP, pretty cool stuff. And then reading from those values to be able to give those granular permissions. Now have that ability. Let's take a really quick look at a tool called Event Inspector as well. So if we think about Puppet's doing all this stuff, right? Let's jump back to our notes really quick. So we've got all these machines that kind of just show up here. They're all in a particular state. You know, you can imagine if I've got 1,000 or 1,500 machines here, you know, it's easy to scroll through 10, but it's not super easy to scroll through 1,000, right? And also, let's say maybe I have 300 of those machines have failed recently, right? Or maybe they've all changed, and I want to be able to know, is there a common correlation between those changes? Looking at this view, I would have to drill into each one of those reports and try to find that correlation myself. So we've actually introduced a tool called Event Inspector that attempts to look at all the most recent changes and it groups them together by the change and then tells you what servers were impacted by that. So for instance, looks like I've had 4 changes that I ran in a no-op fashion just recently in the last 24 hours. And we can see exactly what the change was, what machine was impacted by that. So in this case, it was only 1 machine, but if there was 10 machines, 100 machines, they would all show up here as well. And then we could see exactly what Puppet was trying to do, right? So it looks like we were trying to deploy Tomcat, we simulated the change, and it looks like it was trying to install a package, change a file, modify a service, all that sort of thing. And we can drill into that value even further and see the exact line of Puppet code that was attempting to execute that change and exactly what time that change was kicked off and that sort of thing. So again, high visibility into all the things that are happening within your environment. The really cool thing here is we can extract all this as CSV. It also comes to us in a YAML or JSON format. So if I want to forward this onto like the Logstash or Splunk or something like that, we can absolutely do that.
So the definition for that is show reports that the next
Yeah, so the reports do get saved off in the back end in that structured data. They're really messy to read. So really viewing them through the GUI is probably going to be the cleanest method because you know you can just click on all this stuff. It's very interactive.
So if you change something in through the interface, does it change this on the code, error data, or both?
Yeah, that's a great question. So the question was, if we change something here through the web interface, is that actually making a change on the back end, right? So on the command line, is that changing a file somewhere, or is that updating another tool that we have called Hyra? And the answer is no. So these all act as independent node classifiers. So effectively what happens is, you know, your site.pp, your Hyra, and your console all get merged at runtime in a single catalog of support. So we're not updating Hyra at all. We can't override Hyra values here through the console, but we can't, it's not actually making a change somewhere on the server. Go ahead.
So if you were to, with Hyra, it's easy to keep that in Git, right?
Totally.
And then, so how would you do version control on changes that were made via console?
Yeah, no, that's a great question. That's a big reason why, for a long time, Hyra or even just the standard command line tools were preferred over using the Enterprise Console for really anything, until just recently. So the Enterprise Console is now backed by a RESTful interface on all endpoints. So I can actually curl all of the current configurations, get that out in JSON, and then just put that up in version control. And then I can just do a put if it ever goes down and totally rebuild all my classification.
So whenever you change the classification into a group, so it's not anything passed back from the ENC.
Yeah, exactly. Yeah.
So you have to flexing, like, just like how you can set one directions and then, if I see another, but they're flexing right over.
Yeah, no, great question. So the question was, if we've got something defined in our console, and then maybe I also define it elsewhere, somewhere else within Puppet, what would happen, right? In that case, Puppet's going to give us a duplicate resource declaration error. So it's very much a thing can only be defined somewhere once.
Okay, so it'd be like the same thing if you were to define a code and say, and it would be the same.
Especially if they were declared differently.
My second question is there like an open source like issue like thing for open source?
Yeah.
GUI?
Oh, totally. Yeah. So the question was, is there an open source version of the GUI? So there absolutely is. There is the most popular one is probably the Foreman. A lot of folks probably use Foreman most. It's kind of feature for feature. It's very similar to the Enterprise Console. It's probably the most common one. There's also Puppet Dashboard, which was this kind of a couple reps back. Very basic, but kind of gets the job done. And then I think there's another one called Puppet Explorer that's a little bit newer that was created by the dudes at Spotify, which is actually pretty nice in terms of the reporting stuff. So there's a couple of ways you can kind of get the data out of Puppet. The way we've kind of differentiated the Enterprise Console a little bit from that is in terms of scale. So when we start to look at a large enterprise environment, Foreman's going to start to break down right about 500-600 machines, whereas the Enterprise Console can scale much higher. So that's where a lot of those differentiators are. So open source will get you so far, but after that, highly recommend taking a look at products like this because we actually engineer them for those large scale environments. Go ahead.
Just very quick, what repositories
Pretty much any. So the question was, what repositories do we support? Pretty much anything. Puppet Labs is going to recommend Git. Git and Subversion are probably like 95% of the market, but then there's TFS and Mercurial and Perforce and all of those after that. But yeah, for the most part, everything. Yeah, go ahead.
If I do a yum install Puppet master, does Git come as one of the dependencies required?
That's going to be separate. So if you do a Puppet Enterprise install, that will set up a Git server here in the very, very near future. Not today, but in the very near future. So that'll set up Git server. It'll also bundle in a lot of the different tooling needed to kind of bridge that gap between a version control system and Puppet. So that'll all come out of the box. But with open source, that is something you have to kind of tool yourself. One of the other kind of pieces just that I like to show, and we've got about 10 minutes left here, so I want to be mindful of time. But we also have a unified installer on the back end. So let's take a quick step back here. So we've defined our Puppet code, right? We've got our classification set up, so Puppet's deploying code to all the agents. Everything's great, but how do we get an agent on a machine in the first place, right? How do we do anything and really get started with Puppet? From an open source perspective, there's a lot of other dependencies that you have to worry about. So, if I have, let's say I have an environment, mixed environment, I've got some RHEL 4, some RHEL 6, Solaris 11, and Windows Server 2008, and I've been tasked with managing all of those things. There's going to be a different version of Ruby that's going to work for every single one of those different operating systems, and all of those different dependencies are going to require other things, right? So from a versioning perspective, it can be hellish, especially if you have a mixed environment. So one of the things that we've done with our enterprise product is we actually bundle and vendor all of those dependencies in the installer itself. So your Puppet Master acts as a repository for all your Puppet code, and it takes it takes care of all those dependencies and all that sort of stuff. So let's kind of walk through a really quick deployment here. I'm going to go ahead and restart a service really quick. My Puppet Master because it is not happy. Thank you, Vagrant. So while we're restarting that, I'm going to go ahead and jump over here. I'm going to go ahead and spin up a new box. So I'm just going to do Vagrant, CentOS, C. So right now I'm just going to spin up a new CentOS 6.5 box. This is going to be a vanilla install. It's not going to have Puppet installed or anything on it, right? This is just a bare bones template. So while that's spinning up, basically we're going to deploy out from our master. We're just going to execute a really simple script here to essentially curl down all of the bits that this agent needs to install Puppet to make sure that it's communicating with all the different components of my environment, and that it's fully reporting, it's all configured, it's got all the dependencies, all that sort of stuff. So just a single command here. I wish I could bring that a little bit higher for you guys up front. But you'll see it here in just a second. So once this machine's up and running, basically all we need to do is just run that curl command. It's going to pull all the stuff it needs from the master, and we'll be up and running in just a couple minutes, as opposed to having to find all those different versions and kind of craft, our open source install. So let's just go ahead and SSH onto that box. See. And what's that? Oh, sorry. Yeah, you don't really. There's really nothing to see here. Basically, it's a bunch of numbers are happening, a bunch of things are happening. But really, all it's doing is it's just curling the Puppet agent down to the master. So pretty cool. Go ahead.
Just gonna ask, is there some way to bootstrap a Windows agent?
Yeah. So with Windows, it's a MSI. So we can use like WinRM or execute PowerShell or whatever we need to do to install it. Yep. A lot of times, if you have like a Kickstart script, this would be like the last piece of your Kickstart script, right? Cool. So while this is happening, basically it's going to install the agent and it's going to submit a certificate. It's going to take a couple minutes. So while we're waiting for that, let's talk about the Forge really quick. So how many of you guys are familiar with the Forge? Pretty good chunk. Still some folks who maybe aren't super familiar. Refresh the page real quick. But you can think of, holy resolution. There we go. So you can think of the Forge as kind of like Puppet Labs' app store, right? So I need to manage some Apache and some JBoss in my environment. I don't want to have to create those Puppet modules from scratch, right? I want to leverage the awesome community around Puppet, right? Which is one of the things that makes our product so awesome. We've got over 3,200 modules on the Forge, and these are all, for the most part, free for you to download, free for you to use. There are a couple of exceptions that are only for Puppet Enterprise customers, but for the most part, these are going to work for both open source and enterprise. So, for instance, if we need some sort of new functionality, let's just pick on Apache because we've been doing that all day. Here we can search for Apache. Puppet Labs offers an Apache module. This is actually a supported module. It's got a little supported flag here. Basically, that means that if you're an enterprise customer, we also give you support on these types of things too. So you call us up, you want to call with the Apache module, we'll help you out with that. Let's go ahead and drill into this. It's just a single command to install it on my master. I just need to paste this command onto my master. It's going to install the module for us, install all the dependencies. And then it's also going to give us a pretty good idea of how we can start managing Apache in our environment. So basically this unlocks the ability to write Puppet code and describe different aspects of Apache natively. Go ahead.
We can install that module that installing from all the environments you defined at that time.
Nope.
You have to install it in each environment, correct?
So what you would do in that case is you could either, one, you could specify an environment for it to get installed into, or it's going to pull whatever the environment that's specified in your conf file is. So if you actually pinned a particular agent to an environment, it would just install directly to whatever was, in that case, default.
So what is your favorite R10K or?
Yeah. So so just for everyone in the room who's not super familiar, R10K is a tool that you'll probably hear about a lot. If you're newer to Puppet, don't worry about it just yet, but it is coming. I will warn you about that. So R10K is a tool that's developed by Puppet Labs that essentially hooks your Puppet Master into a version control system, right? So this is that glue that kind of binds those two things together. So essentially, we would use R10K to build out those environments that we were looking at, right? So I need this version of this module, and I need all of these different components, right? R10K would go out to that version control system, pull all that down, and then we'd use Puppet to push it out to the rest of the boxes in your environment. R10K is going to be commercially supported and productized by Puppet Labs. It currently is. But it will commercially release here with Puppet Enterprise 3.8 at the end of March, early April. So that is the direction going forward. Yep. Totally, yeah. Finally, right?
Yeah, right. I didn't figure it out. It's like hard to wrap my head around doing stuff.
Yeah, absolutely. Cool, let's see if our agents are done really quick. Yeah, so here we can see that everything installed, right? I saw no live demo disasters, the agents running, all that good stuff. I would expect that it's submitted a certificate back to the master. Everything within Puppet is all certificate based, so it's all over SSL. Here we can see we've got one node request that's just checked in, right? This is our CentOS 65C machine that we just stood up. Basically, we can set up Puppet to auto-sign certificates if we want, or we can just manually sign them. I'm just going to manually sign it. Basically, this machine can now check into the master and get some sort of classification before we have to validate whether or not it's a legit machine or not. Cool, so we got about 4-ish minutes left here. Open any questions, go ahead.
So, a lot of our machines get rebuilt over and over. Can you have it automatically sign machines that we've heard from, like my Mexico or something like that?
Yeah, if you've got a master list, we can absolutely do that. Yep, and that's a very, very common use case for Puppet, and that's one of the beauties of infrastructure as code, right, is you're not treating these machines as pets, more so as livestock, right, where it's not all about the care and feeding, it's just, I need to patch you. Maybe instead of going through all the effort of patching the machine and wondering if it's going to break anything, maybe I just burn it down, update my Puppet code, and rebuild it and reapply my code to it, right? If I can ensure that it's going to be built in the same fashion, if the build times are relatively the same, why not just do that? So that's kind of the whole idea. So, any other questions? No? All right, last chance, go ahead.
So, what are the variables
Yeah, so question about bare metal provisioning, is that right? Cool, yeah, and thank you for bringing that up. So Puppet Labs does have a tool for bare metal provisioning called Razor. Razor was something that we developed jointly with EMC. It basically boots off a microkernel and just builds up the machine that way. Razor has been in what we call tech preview for probably about a year or so. It is going to be going GA at the end of the month. So for folks that have been using that, Razor will be commercially supported and available. Yeah, it does. Let's see. If you go just on our docs page, we actually have awesome docs. But basically just going to the Razor overview, it's going to tell you what all the different tags and all the APIs and all those different things are. Basically, you just seed a Razor instance with tags. So you say, this new machine that I'm booting up from bare metal is in this data center, it has these different things. Basically, that's going to filter down through that funnel. And so we can build a machine kind of soup to nuts, right? It's got no OS on it, it's going to put an OS on it, and it's also then going to configure as middleware and all that sort of stuff. It comes with a Puppet Enterprise license, I believe, and that's just for the support aspect. Otherwise, Razor is open source.
If you can give a Puppet 4 tidbit.
What's that?
Give a Puppet 4 tidbit.
Puppet 4 tidbits. A lot is in flux right now. So Puppet 4 actually has been, we're going to come out with Puppet Enterprise 3.8 and 3.9 first before we go to Puppet 4. So originally the idea was Puppet 4 was going to drop here at the end of the month. It'll now probably be sometime around October. Basically 3.8 and 3.9 are going to be a little bit more piecemeal in terms of what they're releasing. So things like we're developing a whole bunch of apps that we didn't really get a chance to go into, but things like Application Manager and Code Manager and productizing R10K and Razor and all those things are coming first.
Are they going to roll out the changes?
Yes.
Or is that going to be
Yeah, so for those who aren't super familiar, Puppet's a declarative language, which means that everything that you want has to be declared each and every time. So that's okay until you start getting into things like, if I want to pass in an array of Apache vhosts, right, and I want it to stand all those things up, I need to know how big my array is because basically we can't iterate yet. We will be able to. So iteration will be coming within the Puppet language. But yeah, all those things will be coming. I'm not entirely sure if they're going to be with Puppet 4 or if they're going to be coming a little bit sooner. Yeah, but yeah, a lot of exciting things coming.
Does the language have any notion of inheritance? Yeah, I want to manage all the big parts, but you take care of these 5 things, and so you can only manage these 5 things. But you have to inherit everything that I use.
Totally, yeah. So if we jump back to the enterprise console here, going to classification, we have the concept of a parent group. So let's say I have a Linux baseline, and I don't care if you're getting MySQL or Apache installed, right? You're going to get all of my kind of core security settings and everything, no matter what. That would be a parent group, and that would inherit. Basically, the child group would inherit from the parent. Good question. All right, I think that brings us to time. So thanks everyone. I hope you enjoy your day today. It should be pretty awesome. We got some great sponsors, great talks. Yeah, enjoy it.